Welcome to The Explainer. Today, we're diving into the pretty high-stakes world of cloud forensics. It's a field where the crime scene isn't some dusty room, but a massive global network of servers. I mean, think about that for a second. It's a question that totally stumps traditional detectives. If a company's data gets stolen or an employee's account is hijacked, but all the evidence isn't on a hard drive you can just grab from an office, but it's scattered across data centers all over the world, where do you even start? Yeah, that tangled web is exactly the challenge we're talking about. This is the world of cloud forensics, a whole specialized skill set for unraveling really complex crimes that happen in this virtual space.
So, first things first, we need to kind of get the lay of the land. What makes this new type of crime scene so darn different?
Okay, so the official definition is basically this. We're taking all the core ideas of digital investigation, finding evidence, preserving it, analyzing it, and we're applying them to this huge, shared, virtual world. You can think of it as a specific branch of network forensics, but one that plays by a whole new set of rules. And probably the most important rule to understand is something called the shared responsibility model. The easiest way to think about it is like renting an apartment. The landlord, so your cloud provider like AWS or Microsoft, they're responsible for security of the building itself. The locks on the main entrance, the walls, the roof. But you, the tenant, you're responsible for security in your apartment, locking your own door, deciding who gets a key, that kind of stuff. That division of labor is absolutely critical in any cloud investigation. And criminals tend to use this environment in three main ways. The cloud can be the subject of the crime, say, stealing data that's stored there. It can be the object, where the cloud provider itself is the target of an attack. Or, and this is probably the most common, it can be used as a tool, where criminals just rent servers to launch their attacks against other people. All right, so how do investigators actually work a case in this virtual world? Let's take a look at the playbook. So, this is a pretty standard procedure for capturing evidence from a virtual server. We'll use Amazon Web Services as our example here. Now, I know it looks a little technical, but trust me, the logic behind it is just pure classic detective work. Let's break down the most critical steps. The absolute first thing you do is isolate the machine that's been compromised. In the real world, you'd use that yellow police tape. In the cloud, an investigator uses a digital fence called a security group to block all the network traffic. This is huge because it stops the bad guy from trying to cover their tracks, and it keeps the infected machine from doing any more damage. It perfectly preserves the scene exactly as it was found. Next up, you bag the evidence. Now, you can't just unplug the server, so instead you take what's called a snapshot. This creates a perfect bit-for-bit copy of the machine's entire virtual hard drive at that exact moment. That snapshot becomes your pristine copy of the evidence, which you can then analyze without ever having to touch the original. Now, this might just look like a line of code to you, but I'm telling you, this one little command represents one of the most fundamental principles in all of digital forensics. See that little part there, the O row? That stands for read only, and it is absolutely crucial. It means the investigator can look at every single file on that evidence drive, but they are physically unable to change, add, or delete a single byte of data. It's the digital equivalent of wearing gloves at a crime scene. It guarantees the integrity of the evidence, which is everything if you want it to hold up in court. So, once all that evidence is secured, the real hunt begins. And this is when investigators turn to the single most valuable source of information in the cloud: the logs. Every cloud provider has its own system for logging everything that happens. AWS has something called CloudTrail, Azure calls them activity logs, and Google has cloud audit logs. The names are all different, but their purpose is exactly the same: to record who did what and when they did it. Honestly, these logs are an investigator's best friend. They are the security cameras, the building's sign-in sheet, and the keycard access swipes all rolled into one. They keep a record of every important action, from a user logging in, to a file being deleted, to a brand new server being spun up. And investigators talk to these logs using code just like this SQL query right here. And again, it might look a little intimidating, but the question it's asking is actually incredibly simple. In plain English, this code is just asking the database, hey, can you show me who deleted this specific picture, what time they did it, and what IP address they did it from? That's it. This is the very essence of following the digital breadcrumbs. But it is not always that simple, not by a long shot. Cloud forensics is filled with these really unique and complicated challenges that can stop an investigation cold in its tracks. And these are the big ones. For starters, investigators don't have physical control of the servers. The logs and evidence can be decentralized, scattered all across the globe, or sometimes they just disappear. And when data crosses international borders, it becomes a legal nightmare. I mean, whose laws even apply at that point? These are just massive hurdles. And of all these challenges, maybe the most relentless one is the problem of just evaporating evidence. And it all comes down to time. 90 days. That's it. By default, Amazon's main activity log, CloudTrail, only keeps a record of events for 3 months. So if a company hasn't actively configured longer-term storage, the evidence of a breach that happened 91 days ago could be gone. Just gone. Forever. It puts investigators in this constant, frantic race against the clock. And this all brings us to this huge, central question for our time. As our data, our businesses, pretty much our entire lives move into the cloud, how do we make sure that justice can actually follow? The challenge for investigators, for lawyers, for all of us, really, is to adapt our old systems for this new, borderless world. And that's a question we are all still trying to figure out together.